on page 243. Number 1. A point is equidistant from a segment's endpoint if and only if it is on the segment's what?
I don't know if we ever talked about this one actually. Yeah, I probably didn't mention this one. So this point A is the same distance from these two if it's on the segment's what? What's this called? Perpendicular bisector. Now, when we talked about perpendicular bisectors, we just talked about in the triangle. You guys happen to remember where perpendicular bisectors meant? Probably not, it's kind of hard to remember. Circumcenter.
Number 2. I don't see even, but you guys might know this one. A point is equidistant from the angle sides if it's on the what? If it's the same distance from the sides, what must it be on? What's this thing? Splitting the angle into angle bisector. We did talk about that one. Okay, number 3. The measure of a triangle's exterior angle is blank the measure of either remote interior angle. You guys know what that's talking about? The measure of a triangle's exterior angle, call it A or whatever, I'll call it 1, compared to either remote interior angle. How does angle 1 compare to angle 2 or angle 3? Angle 3 plus 2 equals angle 1, so how does angle 1 compare to angle 3? Or how does angle 1 compare to angle 2? It's greater than. So, greater than. They called that the exterior angle inequality theorem. Number 4, for any real numbers x, y, if x equals y plus the, okay. If x equals y plus z, and z is positive, then what do we know? Okay, if these numbers are positive over here, what do we know about x compared to like these two numbers? Kind of the same thing as up there. It's greater than. So if y plus z add up to x and they're both positive, that means x has to be bigger than both. It didn't tell us y was positive, but they told us z was positive. So y could be negative, but either way, x is bigger than it. Number 5. If an assumption leads to a contradiction, the assumption is what? False. Okay, this was the indirect proof stuff. If an assumption leads to a contradiction, the assumption is false, and its negation is true. So, remember we started by assuming the opposite, like the negation of the original statement. And we showed it was false, so the original statement was true. That's what they're getting at there. I'm going to leave 6 to you, because we just did that one yesterday. Maybe you guys might remember. Number 7, identify each segment in triangle FGH. Which of those, Keziah, which of those is an altitude? Altitudes, remember, basically means height. So which of those lines could be used to measure like the height of the triangle? No. No. Okay, if this was like some kind of leaned over pyramid, yeah. GM, you wouldn't use GM as the height because it goes sideways. If GM drops straight down, you would use that. Yeah, she said HJ. So it's a 90-degree angle. If H was the top, HJ would measure its height, right? So anyway, HJ. Natalie, which of those is an angle bisector? Yes, FL. You can tell because it splits the angle into two, the little arc symbols. Craig, do you know which of those is the median? Median means middle. Well, M is a midpoint, but median is the line that goes to the midpoint. So which line goes to the midpoint? Okay, KM goes through the midpoint, but it's not the median. Median goes from the vertex, yes, to the middle. So it's GN. So Kyle, which one would be the perpendicular bisector? So it's got to be perpendicular, it's got to make 90-degree angle, and it's got to bisect the side. Yes. KM makes a 90-degree angle, and it cuts FH in half. So yeah, KM. These are all segments, so. Should have. Okay, it says use the figure where segment MN is the perpendicular bisector for segment PQ. So it kind of shows it in the picture. It cuts it in half, makes 90-degree angles. Do you guys know, how do we know that triangle PON is congruent to triangle QON? Or actually we could say the big triangle. Triangle MPN is also congruent to triangle MQN. Forget the big triangle for a second. So we know those triangles on the right are congruent because they tell us PO and OQ are the same, right? They mark those both. And then we know those 90-degree angles. What else do they have in common? The triangles on the right. ON. Right? So by side, angle, side, those triangles are congruent. And if you look at the little triangles on the left, those are also 90-degree angles the little triangles have, and they share side MO, so side angle side. Those little triangles are also congruent. So the triangles that look congruent are congruent, is the moral of the story. For number 9, how could I find Y? Do you guys see Y in the picture?
Yeah.
5Y. Yeah, those two, what do we know about those two angles? They're the same, yeah, they're congruent because the triangles are the same, so those angles have to be the same. So 5y equals 4y plus 6.
Megan, what would we do to solve that algebraically? Minus 4y. So that'd be 1y equals 6. I guess that's it. Okay, let's talk about 10 really quick. Might want to take a note here. So it says all those lines, they're going to the midpoint, right? Because it shows it. So those are medians. You guys might have forgotten this, but PV is what we're supposed to find, and it tells us that PS is 12. So the entire median, PS, is 12. How can we find PV? Do you guys remember this trick? Yes. The bigger segment on the median from P to V, the V would be called the centroid. But from P to V is 2/3 of the way. So you just do 2/3 times 12. If they use the smaller segment, it would be the 1/3. Okay, on 10B, it says we're supposed to find VR if UV is 5. I'm not going to draw a whole picture, but basically the centroid's right here. Is that what it looks like? Yeah. UV is 5. Oh, wait, Yeah, UV is 5, VR. VR is what we're supposed to look for. Any ideas? Well, UV should be 1/3 of the whole thing, right? So 1/3 of what value would give us 5? If this is 5 and it's like 1/3 of the way, what's the whole thing gotta be? 15. This is 1/3. This is 1 out of 3 of the way. Then 3 times this would give us 15. So the whole thing is 15, but we're not looking for the whole thing. We're just looking for VR. So how do we find VR?
15 minus 5.
Okay, you can do 15 minus 5, or you can do 2/3 of 15, yes. Alright. C is a little bit easier. It's not a trick question. Number 11. Okay, we gotta draw stuff again. So you guys remember, this will be a reminder for us what's a circumcenter, what's an incenter, and all that stuff. Are we supposed to use both? No, we're supposed to use triangle XYZ. So triangle XYZ, do you guys know what kind of triangle that is? No. It is scalene, but what else is it? Nope. What's this angle up top? Obtuse. Yeah, the top angle is actually obtuse, so it's obtuse triangle. You guys might have forgot this, but obtuse angles, like the circumcenter and the orthocenter, they actually meet outside the triangle. Okay. What kind of lines made the circumcenter? I said this earlier. Perpendicular bisectors. Perpendicular bisectors. So, we need to draw perpendicular bisectors. How do you draw a perpendicular bisector? Well, it needs to make 90-degree angles, and it's got to go right through the middle. So you see how that's 90, and it's in the middle? And if you do it right, all three sides. Should look something like that. My triangle is barely obtuse, so it meets barely outside. Does it say just draw it? What else does it say? Label. Point C. Alright. And on 12 is the end center. What kind of lines made up the end center?
Angle bisectors.
Did you look it up or you remember? You looked it up. Kind of hard to remember. I probably did put this on the test though, so we need to remember it when we get there. So angle bisectors, just imagine the mouth spits something out right through the middle. So kind of like that. Try and draw your line straight. That didn't work very well. And that is I for end center. Centroid. Centroid sounds like center. Which one sounded like middle, median? Yeah, so centroid is made up of medians. And where do medians go from and to? They go from the vertex to the middle of the opposite side. So from the vertex to the middle. Vertex, middle. Probably supposed to put C for centroid, I imagine. Nope, G for centroid. They threw a curveball on me. It's not cold enough or warm enough outside to have AC on. Feel better?
What? No, just quite an interesting turn of events.
Okay. Ortho center. You guys, which one have we not used yet? Altitudes. How do you draw an altitude? It's like you're measuring the height of the triangle. So you go from the very top, the vertex, straight down to the bottom. Should make a 90-degree angle. But you do that for each vertex, so you might want to turn your paper just to look at it carefully. I don't think I drew this angle obtuse enough. Oh well, it's not a very good drawing, but I'm gonna settle here. O is the ortho center. inscribed circle. So for triangle DEF, just looks kind of like a normal acute triangle. It says we're supposed to draw an inscribed circle. What does inscribed mean? Inside. And each side of the triangle should be touched. So, kind of missed on that one. Looks something like that. Alright, and then 16 is draw the circumscribed.
This one was like all around, right?
Yeah. So, what needs to happen? Let me go down here. It has to touch each vertex on the circumscribed circle. So it's got to touch there, there, and there. The only way that's going to work is if most of the circle is like up here. That was pretty good. A lot of work. Okay. On 17 it says, as specifically as possible, describe the location of each point in a right triangle. So I think I'm just going to make you guys draw the right triangle, and maybe you'll remember as we go, like where the point is. We did this once upon a time. So on 17, circumcenter. So what kind of lines made the circumcenter again? Perpendicular bisectors from like number 11. Okay, so you need to draw a right triangle. Try to be kind of neat or else it won't look right. Where are all the perpendicular bisectors going to meet? Kind of swing and miss there. Kind of missed a little bit there too. Yeah, that looks better. Where are they meeting at? Midpoint of hypotenuse. Hypo 10 use. So perpendicular bisector means it's 90-degree angles and it splits them in half. That's what you have to think about as you draw. Alright, 18 says orthocenter. What lines made the orthocenter? Altitudes, right. So where would the altitude, no, we need to change colors on this one. Where would the altitude from this vertex be? Yeah, straight to the ground, so it would just be that leg. Where would the altitude of this vertex be? This is the ground now, so straight to the ground, it would be the other leg. Where would the altitude for the 90-degree vertex be? Straight to that ground. Alright, where do they meet at? The vertex of the right angle. pointing. Hold on, pause. Okay. 19. Centroid. What kind of lines make the centroid? Median. So it goes from vertex to the middle, vertex to the middle, vertex to the middle. Kind of missed. Oh well. Too late. Where do they meet at? Some kind of random place in the middle. Let's see what the book wrote. Interior of the triangle, 2/3 of the distance from each vertex. Yeah, okay. Yeah, remember from earlier, the medians are 2/3 of the way. The centroid is 2/3 of the way from the vertex. Well, I don't want to write all. We'll just put middle of triangle, or we'll put inside the triangle. Which one did we skip? What kind of lines? In center meets is where the what meets? Angle bisectors.
Are you doing 20 or 21?
Oh. It's where the angle bisectors meet. I have it, I'm just doing the odds. That's pretty close. Well, they meet somewhere in the triangle. What the book put is in the interior of the triangle, equidistant from each side. So yeah, it's called the in-center because it's the inscribed circle's center. So it's equidistant from each side. Inside triangle. Equidistant from side. I guess I'll write that. Okay, number 21. Show that x 5, 7 lies on the perpendicular bisector of AB, with A being 2, 3 and B being 9, 4. And x is at 5, 7. Okay. If x is on the perpendicular bisector, gosh, this is a mess. If x is on the perpendicular bisector, what do we count? Okay, we talked about this on number 1. We know that x has to be the same distance from A as from B. How can we show that A is the same distance from x? Or x is the same distance from A as it is from B? How can we show distance? Distance formula. So basically they want us to show that x is the same distance from A as B. How do we find the distance from x to A? Okay, use the coordinates here. So square root of x minus x squared plus y minus y squared. that would be -3 squared is 9. 3 minus 7, -4 squared is 16. So we got 9 plus 16 is 25. Square root of 25 is 5. So basically we need to do the same thing with x and b to show that its distance is also 5. So square root of x minus x plus y minus y. 4 squared is 16. -3 squared is 9. So it's 16 plus 9 again. So square root of that is 5 again. So basically it's just like show your work kind of a deal, like this part. Well, all of it really is the answer. So I guess 22 is using that picture. Find the coordinates of the circumcenter. What a mess. Let's skip 22. Alright, on 23, list all angles that must be larger than angle 2. This might seem easy, but you can't just list the angles that look larger. You gotta list the angles that you know for sure are larger. I really hate this thing. I screwed it up. Does anybody know what angle has to be for sure larger than angle 2? No. No. Okay, we talked about this on, what number was it? 3. The measure of a triangle's exterior angle is greater than the measure of either remote angle. So what's an exterior angle to the triangle that angle 2 is in? Yeah, but angle 2 is not a remote interior angle to angle 1. What else is an exterior angle?
5 or 6.
Okay, 5 is not an exterior angle because it's not an angle created by an extended side. 6 is an exterior angle and it would have to be greater than 2 or 4. So angle 6 this is kind of hard, but we know angle 8 has to be greater than angle 6 because 8 is an exterior angle to angle 6. So angle 8 would also be on the list. Alright. We will